After having learned addition and subtraction of vectors, let us try to understand a thing or two about position vectors and displacement vectors. Right? Let us say we have an object which is moving, and at time t1 it is at, say, a location, this location, let us call this location A, and it is at this location at time t1. Right? Now, if I want to describe this location, what I can do is, one way of doing it is I can identify the x and the y coordinates of this particular location. Right? I can call this x1. Similarly, I can identify the y coordinate, y1. Right? And I can say that the object at time t1, the location of the object, or the position of the object is at time t1, the object is at a x1 y1. So this is one way of representing or describing the position of an object, where it is at a given point in time. We can also use a vector to identify or to specify the location. For example, what I can do is I can join this line from the origin. So I can draw a vector like this starting from the origin O. Now, if I know the length of this particular vector, meaning the magnitude of this vector, right? Let us call this L1, right? And I know this angle theta1. Supposing I know this angle, the angle that this particular line or the vector makes with the x-axis, then I can very easily identify the location. For example, I can say that at time t1, the position vector of the object is OA. Right? So this particular line, which joins the origin with the location of an object at a given point in time, is known as the position vector of that particular object at that point in time. Let me specify this once again. At time t1, the position vector of the object is OA, meaning that at time t1 the object is at A, and the position vector is OA with reference to the origin. So this is another way of describing the position of an object, right? As I said, we should know L1 and we should know theta1. If we know these two, we have the magnitude as well as the direction of this vector, and we know the position of this object. Now, what may happen is that since this object is moving, after some time the object may reach some other location. Let us say it reaches location B. This location it reaches at time t2. And again, what I can do is I can join this particular vector. Right? I can join these two. Right? And now this vector OB, right? And of course this is L2 and this would be theta2. So I can make a statement that at time t2, the position vector of the object is OB, right? And of course I need to know L2 and theta2. So this is the position vector after time t2 minus t1, right? Okay, so this is how we represent position vectors. So they identify the location of the object at a given point in time. Now, what would happen if I join these two lines, right? Say for example I join AB. When we did subtraction of vectors, the method that we used was that from a common point, supposing we want to find out vector A minus vector B, I want to subtract B from A. Then from a common point, I'll show both the vectors. This is vector A, for example. This could be vector B, from example. And if I join it like this, I end at B, then I get vector B minus vector A. Similarly, what I can do is that I can join these two vectors over here. Right? I can join these two vectors over here, like this, right? Since from a common point I have drawn vector OA and vector OB, right? This particular line will give me OB minus OA, right? So this particular vector AB is equal to OB minus OA. And I'm sure now you have guessed what vector AB will represent, or what OB minus OA will represent. Yes, it represents the displacement vector. So what we have done is that displacement of the object from A to B also we have represented in the form of a vector, right? This vector will give me the displacement of the object. It will give me the magnitude of displacement. The length of this line AB would give me the displacement in magnitude, whereas the angle that this line makes with this particular vector or with this vector or with x-axis will give me the direction in which the displacement has happened. So we have represented the displacement in the form of vector. To conclude, we say that the displacement vector, this displacement vector, is the difference between the final and the initial position vectors. This is the final position vector OP, this is the initial. The difference between these two gives me the displacement vector. Right. So this is all about position vector and displacement vector. In the next video, we will look at a few more types of vectors like the null vector and the unit vector, and then we will talk a few things about how we can resolve vectors. Thank you.